Okay guys, have you all run this example successfully? Have you seen rate limiting in action? Good? All good? Okay, so we are kind of almost done for the day. We just have this last kind of more of an motivation kind of discussion, right? So just to show you what next, right? So what you have seen till now is all the last 5 years of like up to last 5 years of engineering research and industry state. So we just wanted to show you a little bit of what's happening right now, right? Like last few years, last 2 years, the more exploratory, the more edge of the research, right? So essentially, there is this whole drive towards multi-cloud, right? And I think it will become kind of obvious to you as we go why this is happening. But we just wanted to use this session to show that. So this is kind of a projected, world how the future will look like, right? So you have different cloud vendors, cloud providers, and you have different softwares running on all these providers, and they're all talking to each other. And there are also some what you've shown here as a factory symbol, right? So there are also some enterprise data centers or on-prem data centers, right? And they're all intercommunicated. This is kind of the future we see, and this session is just to show you that, right? But why would someone do this such a complicated thing, right? Like there is so many moving parts, there is so many connections, there's so many. Why would someone go to this kind of complicated mess? Wouldn't it be easier to just go with one cloud? Wouldn't it be easier to just have one data center, right? But why is someone forced to do this? So we have a number of reasons, so we'll just go over some of them. So the first thing is obviously in today's world, users are like all over the place, right? Nobody's starting a company just for one geolocation. They're starting a company for the world, right? The next startup is trying to capture the world market, right? So your users are going to come from all over the world. So you can't just have, there is no way you can just have one data center anymore, right? That's the new reality. You have to move and have your points of presence as close as possible to the user so that it's higher quality of service for them. The closer you are, the faster things are for them, right? So this is like a necessity now. You have to go to different places in the world. You have to run your services as close as possible to the end user, right? So, but the thing is, it's not as easy as you just said it, right? Okay, where do you go? You go to a cloud provider. So each of the cloud providers have their own locations, right? They try to cover the world, but they have their own locations, and that is not necessarily exhaustive, right? So you might find in one country a particular cloud provider is giving you the best option in terms of closeness, but maybe that company is not even there in some other country, right? At that point, you are forced automatically, you have to go to a different company in a different country, for example. But it's not just that. It's not just that your users are all over the world. It's also that you have different kinds of services being provided to you by different cloud companies, right? So the thing is, when we as users, we think of services, we think of software as a service, things like Google Docs, right? That's the kind of cloud services that we use, right? But if you think about enterprises who are running on the cloud, it's not that kind of thing. It's all sorts of internal stuff, right? It's not a service, it's compute. It's the kind of VMs they give you. It's the kind of storage offerings they have. It's the kind of containers even, right? So, and all sorts of platforms or infrastructure that companies want to rent. It's not just services, right? But it might be services also. So it can be all over the stack essentially. So this is just an example to show you 2 or 3 differentiated services. That's the word we are using here. So this, what you see on the left, is a kind of an IoT service from AWS, Amazon. So what do you mean by IoT service, right? So you have IoT devices, fine, but if you're a company who is just manufacturing, smart lights or something, you're not really, it's not your job to worry about how you're moving the data for analytics and stuff, right? So you want to use some service which will make management of those devices easier, or even say, this is device management, what you just example you just talked about. But everything that you do with IoT, every single aspect of it, there are many aspects, right? You have to manage your users, you have to manage the data streams coming out, you have to run analysis on them. So Amazon, for instance, in this example, has come up with an layer of set of IoT. This is the kind of internal service that I was talking about, right? So this is something that is useful for those clients. So they might like to choose this, right? I'm not saying that Google or IBM Cloud doesn't have an IoT service, but I'm just giving you an example here of Amazon's IoT service, right? So again, another example here on the right top is essentially functions, right? If you hear this FAS, fast movement. So we have talked about services in all of this school, but there is something even smaller than microservices, and that's functions, Lambda, the Lambda architecture, right? So it allows you to run small pieces of code. You don't even do anything else on demand, right? It's cheaper in some conditions, in some cases, right? So similarly, this another example. You obviously this I think you might all have heard of Gemini, right? Essentially Google's answer towards the ChatGPT movement. So if you are interested in using Gemini, you have to go to Google Cloud, right? Where else will you go, right? That's the kind of service that added service that they're providing on top of Gemini. You have to take Google Cloud's offer, right? So can just by looking at this table, the first column, can somebody guess what these things are? What those numbers are? GPUs, yes. So this is a table from NVIDIA's page. They are the biggest GPU creators, GPU providers. So the top list is kind of different GPU models, right? And on the left you see the different clouds, right? And if you see this matrix, it's all over the place. There are some companies who give you particular GPUs, and it's not necessarily that on a particular geographical data center, say a Chennai data center that IBM has, or a Mumbai data center that Amazon has, right? You have no guarantee that that particular GPU model that you're after may or may not be there, right? But if you're in the market to hire, as in for rent, GPUs on the cloud, then you again have this problem of having to go to different providers, right? So just because it came to GPUs, I'm just giving this example of this thing called tensor processing unit, if people have heard. So essentially this is a creation of Google. So it is their answer to GPUs, right? So what they've said is, I mean, obviously today GPUs are not, what are GPUs used for, right? Apart from gaming, they're mainly used in this AI, and all this pushes towards, companies are not interested in gaming, right? So enterprises are interested in renting GPUs for AI workloads, right? So this example is like Google's answer, where they have created their custom GPU alternative, which they call TPU, tensor processing unit, and under certain conditions it outperforms GPUs. And the thing is, you can only get this on Google Cloud because this is a Google creation, right? You're not getting this on the market. You can only get it for rent on Google Cloud. So if you're interested in having TPUs, you go there, right? You're forced to go there, in other words. Again, just for completeness, because I said that it's not just Google as a custom GPU alternative. Every company has their own custom chips that they do, right? So NVIDIA itself has a Tensor Core, which is now embedding into their GPUs. This is IBM's AIU, again AI focused chip. The things at the bottom are Amazon's chips. So it's interesting to see here, this thing on the left is something they call Inferentia. It's a chip which is meant only to optimized for AI inference, right? And the thing on the right is another chip from same Amazon, which is optimized for training, right? So if you think about it, AI life cycle, the company puts in a lot of data, gets in, processes data, and then trains models, right? That's the training process. Once that is done, the model is actually deployed to be used. When, for instance, you go to ChatGPT and you type, you're not training it at that point, you're using the model, you're just doing inference on the model, right? So that's a different process. If you go down to the internal working of it, it's a slightly different process from the way training works, right? And in this case, Amazon has actually come up with two different kind of chips, optimized for two different things, and the obvious answer is cost, right? So if a company is going to rent this only for this purpose, they can get more performance for lesser cost, right? Okay, so any idea of what this is? Storage, okay. Any guesses? This looks like some military compound in the movie or something, but it's real. Any other guesses? GPU cluster, okay. Nice. Servers, okay. So this is actually something called Amazon Snowball. It's like a suitcase, right? But it's actually 50 to 80 terabytes of storage. But it's not meant for storage, right? It's not that you're getting this just to store data, right? It's actually an Amazon service. It's not a product. You're not buying it. It's a service where they will, if you fill in the form, they will literally send you one of these suitcases, and you connect it to your local data storage. You can upload data onto that thing, or as long as it fits in this, and then you then ship it back, right? So obviously Amazon is good at this. So they come and collect back the suitcase from you. They take it to their data centers and they upload it onto their S3 bucket. So S3 is an Amazon normal storage that you use. And after that point, your data is in the cloud on Amazon cloud, right? So do you see why this is useful, right? So if you are a new company that's starting up today, you just go to S3 and you can get data storage, right? But no, you're an older company, or you have factories, or you have lots of existing data, right? At that point, you can't just move them. The idea here is you're not actually using networking, right? You're using the road as a network, right? Instead of sending packets from your data center to Amazon data center, you're literally putting it in a suitcase and sending it on the road, right? That's literally the networking that's happening. But what if you have more than that 50 to 80 terabytes, right? What if you had a lot more data than this? So Amazon has a solution for that also. This is also a service, right? This is literally a container on a lorry. They will send you this. If you call them up, they will actually send you this to your location, and it can store up to exabytes of load full. It's just full of those suitcases, right? This is a service. So this is also a service, right? This is like a cloud service. Right? And if you want this cloud service, you have to go to Amazon. None of the other cloud providers are doing this kind of sending lorries to your compound, right? So obviously not all services are for this kind of thing. So again, any question, right? What is this? Any guesses? Quantum computer, yes. So this is an IBM system to quantum computer. It is real, it is not sci-fi, it is not a movie, it's an actual machine that is running today. So this is the same thing inside the box, right? If you open up that central panel, you can actually see this thing hanging there. It has a lot of cooling things for cooling and things of maintaining the stability of it. But the idea is this is a new kind of quantum machine, right? And you cannot buy this quantum machine today. Again, same thing. This is all super exploratory. Things change. They're working on it. But what you can do is you can go and you can rent time on this quantum machine, right? This is a cloud service. So today this is a cloud service on IBM Cloud. You can go and you can pay as much as you want, hourly rate, to rent this thing, right? This is that URL on that. This is that web page, right? So it's just another service on the IBM Cloud website. So there's a runtime, you have a simulator, and it's actually quite expensive if you see. It's 133 rupees per second on that thing. So it's pretty expensive to rent that thing, but you have that option, right? So a lot of exploratory research is going on in quantum, especially in these hard sciences, right? Chemistry, biology, physics. They're trying material sciences, this kind of thing. So they can kind of write their code, test locally on the simulator, and at some point they can try it on the cloud also, right? It just helps in this kind of research. So yet again, why you will want to depend on a third-party cloud for a service which you can't get anywhere else. Right? So, but it's not always all hi-fi, fancy lorries and quantum machines, right? It can be for a very simple, very grounded reason. It can just be cost, right? And this is not to be taken lightly. Cost is like it's a very important factor in every company's path. And everybody obviously wants to take the cheapest option if you can get it, right? And obviously cost is not homogeneous, right? Every service has a different cost. Every cloud provider offers the same service. That same service might be cheaper in one geolocation on one data center from one provider. You get the idea, right? So this is from a very recent blog, not even a week back, I think, where they kind of compared prices across few cloud providers for some services, right? So if you see, for instance, they're talking about cloud storage here. And that's like cheapest is on Azure, for example, right? Microsoft. And then things change, right? It's not just for storage, like for machines, for if you want to rent out VMs, right? There can be on-demand rates, which is like if you just go and book it now, and they can also be like if you want to take for a longer duration, the rates are different, for instance, right? So, and then again, if I say VM, I can't just say leave it at that, right? I can't just say VM. VMs are these days are super specialized. So they will be either compute optimized or GPU optimized or memory optimized or storage optimized. Depending on your workload, they have actually gone to that level of giving you differentiated VM types, and their costs are obviously going to be different. So again, some more numbers just to show you that different rows are the cheapest option for different VM types, right? But there is also this category of, okay, do you know what this is? The thing on the right, this picture? Server. Okay, any other guesses? It's a rack. Okay, any other guesses? It is that, but I'm looking for more specific. Okay, that works, but something more specific. So this is an IBM System Z. Right? So we saw the quantum system, but that's the newest, right? This is kind of one of the oldest things of IBM. This is a mainframe, right? So this thing has existed from 1960s, 1950s, since when computers were there, right? So this is kind of the powerhouse. This machine is kind of the powerhouse for a large set of core things that runs the world, right? Things like banks, things like telecommunication infrastructure, things like factories, manufacturing, right? So and part of the reason is because that was the option then, right? In 1960s, what kind of computer you have to go for single large machines, right? This machine is fully redundant. It has multiple cores. It has all sorts of redundancy things that are, and it's very expensive, right? It's like, I mean, $500,000 or $1 million for one piece, that kind of thing, right? And the thing is, these kind of old data centers are always going to be there, right? They are there and they are there today. They will be there in 60 years from now, because that's the kind of data inertia and the kind of quality of service we expect, right? You're not a bank is not going to go and try out a new thing just like that for fun. And in fact, half the program, actually all the programs you write on system Z are like written in COBOL, right? Which you don't even have programmers to understand those programs. You kind of just hope everything is running, you do maintenance, you don't want to change anything, and you slowly try to move, right? That's the kind of attitude you have, because these are important things, right? And for the system Z point of view, it's like every version, there's a responsibility on it to be completely backward compatible. So the code that was written in 1960 still runs 60 years later without changes, right? That's the kind of system. So this is never going to go on the cloud, right? This is the example I'm trying to say. Even IBM has System Z, offers System Z on the cloud, but there are no new customers for it, right? It's always these old customers, and they are not going to move from their locations for good reasons, right? So given all of these reasons, you can kind of understand that there is going to be this mix of different clouds, mix of on-prem, off-prem. You have all of these different options, right? And reality is that mix. It's always going to be that mix, which is why this whole multi-cloud is like inevitable, right? There is no other way around it. You're always going to have different things, and you have to make them work together, right? So one good thing that has happened is this once in the last 10 years is the standardization around Kubernetes, right? What we have seen has become the de facto standard for all cloud providers, for all container-based deployments, right? So the thing is, what you see all of these logos here, this is the Kubernetes that we ran, just plain Kubernetes. Everything else is from a different company, right? Each company has their own version of Kubernetes service that they provide on their cloud. This is Amazon, this is Azure, this is OpenShift, is Red Hat. All of these are like different flavors you can think of, almost like distros. But the core YAMLs that you have written today will work on any of them, right? That's the kind of standardization that has happened, partly by force, partly by convenience, but it's lucky for all of us that has happened. So that allows you to actually reuse and move from one cloud to another cloud in a much easier fashion, right? If this was not there, it would have been a complete nightmare. What you have working on Amazon in one place, the kind of code and kind of stuff you will write will look completely different from Google in another place, and there would have been no way for you to go from A to B, right? So this kind of standardization has allowed people to use the same thing to move between platforms much easier, right? So that's one of the good things. I just gave this example to talk about vendor lock-in, right? Is this diagram making sense to you? Like, what are you taking away from this diagram?
The ecosystem.
Sorry? Ecosystem, right? So the thing is, vendor lock-in is very good for any company. For Apple, it's very good. Once you get on the phone, first of all, you're not going out of the phone. But if you are going to buy a watch, it is going to be an Apple watch, right? You don't have that kind of lock-in in Android, right? There are 10 companies, 20 companies. You can buy any of those watches, right? And it'll all work, right? That's the kind of interoperation that you have. It's obviously very good for Apple, vendor lock-in, that is, as a concept. But it is very bad for the rest of us, right? For its competitors or for the users, right? Once you get logged in, you have no choice, right? So luckily what has happened with this movement to cloud is, on the compute that you have seen, services, deployments, pods, all of this has got standardized. There is no vendor lock-in. So once you create one, it's very easy for you to move from one cloud provider to another cloud provider. And these days, we do the same we use Kubernetes on on-prem data centers also, right? That's the kind of service that, say, Red Hat OpenShift provides. So it's a flavor of Kubernetes, but like Red Hat does for the Linux operating system, it provides enterprise support, and it allows you to run it on your own data centers. So you run the same Kubernetes on your own data centers as well, so that it's easy for you to, even if you want to move out tomorrow, you have that option, right? So we have seen kind of why we have multiple clouds, why it's the reality, and why it's good for people also, I would say, right? But that does not make networking simple, right? I mean, that may be good for others, but as network engineers or network researchers, it has made our life very hard. There are so many layers, right? You have seen some of those layers. We have seen, actually CNI is not even there in this diagram, right? The person who made this diagram is left with CNI. So there is CNI here, you have seen kube proxy today, we have seen service mesh, we have seen sidecars, and finally the application is somewhere hidden all beneath all of that is the application somewhere, right? So networking is like lot more complicated than what we used to have when it was just one single server and one single client, right? That was the easy world. Now networking is a hard world. So we have seen all of these solutions, which is what is there in Kubernetes, and that is very nice for a single cloud Kubernetes, for a single cluster Kubernetes, right? But none of the solutions that we have seen here can handle this multi-cloud world that we just talked about, right? So this is all good. You can see the difference between something like compute and network. It will become kind of obvious to you. For compute, it is automatically a single entity thing, right? You were talking about compute of one pod. If it's running on Amazon, it's good for you. You can just move it tomorrow to Google Cloud, right? But if it's networking, it is never like that, right? Networking is always about two entities. At least two entities have to talk to each other. There is no networking otherwise, right? And the moment you have two entities talk to each other, then you have this explosion of complexities. If the two are the same cluster, same cloud, everything we have seen yesterday, today applies, right? The moment those two go to different clouds, different clusters, we're gone, right? None of the solutions we have seen today will work. This is just to show you that though there are a lot of layers you have added, it's not enough. We are not there yet, right? And just to again flash this diagram to show you this multi-cloud and so this is just to bring you to this tip of this engineering research, right? That what we are working on these days is this thing of multi-cloud networking, right? So this is not a solved problem yet. Different companies are trying different things. There are different open source solutions. There are lot of papers all coming out last year, this year. This is the time frame I'm talking about. There are a lot of different approaches, right? But it is not solved. In the sense, there are still a lot of challenges. There are still trade-offs. Every solution is very poor, performs very poorly on one aspect or another aspect, right? So there is still enough space there for research to fill the hole. So just again to give an example, we have seen Istio today. So they have a multi-cluster extension, right? Something more they have added on top. Istio is already complicated. You already have sidecars, service mesh, etc., etc. And now we are adding some more things on top to make that work, right? So another example is Copper, another open source project. You can go have a look at it if you're interested. It's like just the n+1 layer to what you've seen, right? And just from our point of view, what we have been working on, so IBM has a product which has been recently released. We personally, Priyanka and myself, have worked on this product, same space, right? Same challenge, getting networking working across multiple clusters. Right? But that doesn't mean it's still, I would say it's still not solved yet. We are also working on the academic side of things. We are working on couple of different ideas and research ideas. It's still an open problem, right? That's what I kind of wanted to convey. Multi-cloud networking is an interesting, challenging research area, right? Okay, I think that is pretty much what we had. Hopefully that has given you an idea of where we have come so far in the last 10-15 years and what is going to happen next in the next 3 to 4, 5 years maybe, right? That's the idea. Okay, thank you guys. So we'll have the quiz now quickly, short 5-6 questions. Link has been shared on Slack. Otherwise you're good to go. So tomorrow we'll be shifting gears. We'll be looking at eBPF. It's something slightly different. We'll again go back down into networking. After that, on Friday and Saturday, we'll be back with you for some more sessions on application level networking, right? So we'll go up and we'll only focus on the application side of things. So layer 7, right? Things like HTTP, things like gRPC, things like message queues. So that's the agenda for the rest of the session. Thank you.